Imagine a silent, colossal explosion happening 93 million miles away. A bright flash erupts from the sun's surface. It seems distant. It seems harmless. Yet a wave of energy and particles hurtles through space. Some are heading directly for Earth. This is space weather. Space weather equals changing conditions in space driven by the sun. Our technology-dependent world is vulnerable to these cosmic tantrums. In the next few minutes, we'll explore this force of nature. We'll look at what it is, how it works, why it matters. The sun is not calm or steady. It's dynamic and turbulent. Its magnetic field twists and snaps. That activity creates sunspots. Sunspots are cooler, darker areas. Magnetic energy can release as a burst of light and radiation, a solar flare. A bigger event is a coronal mass ejection, a CME. The sun can expel a massive cloud of magnetized plasma. This solar wind can travel millions of miles per hour. When outpourings reach Earth, they interact with our magnetic field and upper atmosphere. That interaction is a geomagnetic storm. Think of Earth's magnetic field as a protective bubble, the magnetosphere. It usually deflects solar wind, but a powerful CME can compress and rattle the shield. It funnels energetic particles toward the North Pole and the South Pole. Particles collide with atmospheric gases like oxygen and nitrogen. Those collisions excite gases and cause them to glow. The result? The aurora. Space weather is constant. The sun breathing, sighing, and sometimes shouting. Mostly, Earth's defenses handle it unnoticed. The auroras, the northern lights, the southern lights are the gentle signs. But the same forces can turn dangerous. A strong storm can overwhelm our shield. It can induce powerful electrical currents in space and on the ground. The invisible currents generated by a major solar storm pose a profound threat to our power grids. Long transmission lines that span hundreds of miles can act like giant antennas. They pick up the electrical energy induced by the storm. This sudden surge of direct current can flow into electrical transformers. These transformers are designed for alternating current. The unexpected DC load can cause them to overheat, melt, and fail catastrophically. The failure of just a few key transformers could trigger a cascading blackout, plunging entire regions or even continents into darkness for weeks, months, or longer. Our presence in space is also directly in the line of fire. The thousands of satellites orbiting Earth are critical for modern life. They handle our global communications, television broadcasts, financial transactions, the global positioning system. During a solar storm, the upper atmosphere heats up and expands. This increases atmospheric drag on satellites in low Earth orbit, causing them to slow down and potentially fall from the sky. High-energy particles from the sun can bombard a satellite's sensitive electronics. This can cause malfunctions, data corruption, complete failure. Losing these eyes in the sky would disrupt countless aspects of our daily lives. The storm's effects ripple through other systems as well. High-frequency radio communications used by airlines, used by emergency services, can be completely blacked out. The same atmospheric disturbances that cause radio blackouts can also scramble GPS signals. To understand the potential for devastation, we must look to the past. In September 1859, the most powerful geomagnetic storm ever recorded struck Earth. It is known as the Carrington event. It was named after British astronomer Richard Carrington, who observed the massive solar flare. In the 19th century, the most advanced electrical technology was the telegraph. During the storm, telegraph wires across Europe and North America spontaneously shorted out. They threw sparks that shocked operators. Telegraph paper even caught fire. Some operators disconnected their batteries and sent messages using only the storm-induced current. The auroras were so brilliant and widespread they were seen as far south as the Caribbean and Hawaii. People in the Rocky Mountains woke thinking it was dawn. They reportedly read newspapers by the red and green auroral glow. In 1859, it was a curiosity. Today, it is a terrifying benchmark. A Carrington-class storm now would be a global catastrophe. An informed, prepared public and resilient infrastructure turn fear into readiness.